In today's class, we're going to look at dimensional analysis of units. I would emphasize that this is a subsection for AS students only. So if you're in AS, stick with me as we break it down. So by the end of this class, we should be able to derive the SI units of physical quantities based on the definitions of the physical quantities. We should also be able to prove the homogeneity of units given a particular equation. So let's quickly get into the objective number 1. But it is important to remind you that one of the advantages of the SI system of units is that it is a coherent system, meaning each physical quantity is assigned one unit. So since all derived units are derived through multiplication, division, or mixing the two of them, we should be able to break down all derived quantities back to their base units. That process of breaking down derived units is what we call dimensional analysis of units. Please take note, since derived quantities are obtained through multiplication or division or both, homogeneity is used to prove equations. This is particularly for objective number 2. An equation is homogeneous if the units on the left-hand side are the same as the units on the right-hand side after breaking them down to base units. So let me just take you through an example. Here is a question. Using dimensional analysis of units, show that a Pascal, the SI unit of pressure, is equivalent to a kilogram per meter per square second. So we want to see whether a Pascal is a kilogram per meter per square second. Now, for us to come to this point, we need to understand the requirement of the question. The question wants us to compare a Pascal as a base unit. Is it going to give us kilogram per meter per square second if we break it down to its base units? We define pressure as force per unit area. So we can safely say pressure is force per unit area. Therefore, the units of pressure are equivalent to the units of a force divided by the units of the area. Once you introduce square brackets, you're now dealing with the units of the physical quantities in the square brackets. But it is important to note that force is equals to ma according to Newton's second law. Therefore, the units of force are the same as the units of mass times the units of acceleration. Therefore, we can safely say the units of force are kilograms times meters per square second. Also, it's important to note that area is the same as length times length. Therefore, the units of area are equivalent to a meter by a meter, which is giving us square meters. Now, with these two units, we can come back here and say the units of pressure are, what is the unit of force? Kilograms meter per square second. So where there is a force, we're going to put kilogram meter per square second divided by area, which is square meters. Evidently, this meter here will go with 1 on the denominator. What remains is the units of pressure are kilogram, this kilogram which remained up there, per meter, this meter which remained as a denominator, per square second, this per square second over here. So with this, we can safely say the Pascal is a kilogram per meter per square second. Kilogram per meter per square second. Then you can safely write shown in your exam. Don't just write shown after writing mumbo jumbo. When you have derived all the units and they come out nicely, you can, with so much pride, write shown. Let me give you another example, then I will leave you with one for practice. Now, example 2 reads, determine the SI base unit of work done by an object. I know you are aware that the SI unit of work done is a joule, but the key question here is the SI base units. It's not just units, but they should be base units. So we really need to break down a joule into its base components. In other words, the requirement of the question is using the definition of work done, express a joule in form of its base units. So we'll go to the definition of work done, and we know that work done is force times the distance moved by the force in the direction of the force. So we will say work done is equals to force times distance. Therefore, the units of work done are equivalent to the units of a force multiplied by the units of distance. But we know that the units of a force, according to Newton's second law, they are equivalent to the units of mass times the units of acceleration. F is equals to ma. Therefore, the units of a force are equal to kilograms meters per square second. So the kilograms from the mass is multiplying the meter per square second from the acceleration. Also, we are aware that the units of distance are meters. Why? Because distance is length. Now, joining these two, we can now safely say the units of work done are equivalent to the units of a force. The units of force, we found them here, which is kilograms meters per square second, times the units of distance, which are meter, which were found here, times a meter. This will consequently give us the units of work done as kilogram. Now a meter and a meter here will give us square meters, and we remain with our per second. So the units of work done, putting them together, they are kilograms square meters per square second, which is equivalent to a joule, the one you are used to. Take the question and attempt to solve it and earn yourself 3 marks. See you in the next class.